Need more devices? Here's another
All
device.
my devices.
Shall I hold your device?
You can hold the first two.
Yep.
You can put it down there if you want when you're done, and I'll hold on to this one. Okay, so as you said, I'm JP Meijers. I'm the creator of TTN Mapper. I'm just checking, I don't recognize only a few faces from last year. Who of you were in my talk at the previous conference? 1, 2, 3, 4, not that many. Okay, so TTN Mapper is a community effort to map the coverage of the Things Network. I live in Cape Town, South Africa, and in 2016 I started building the Things Network around my city, around Cape Town and around the area. While living in South Africa, also because I'm working in the LoRa field with TTN, I got involved with other LoRa projects. So I'm helping people design and build their LoRa networks in Southern Africa. So in this photo, you see some of our, well, I'm not sure if we can call them customers, but some of the people we work with. And in this picture, they're actually standing with this exact same box on the banks of the Zambezi River in Zambia, mapping coverage of the Things Network there after we installed the Things Network gateway there. What you see here is a screenshot from TTN Mapper. That is all gateways that has ever been seen by TTN Mapper on the Things Network. So this is since in 2015, shortly after the Things Network started, TTN Mapper started monitoring gateways. The reason for that is TTN Mapper needs to know where gateways are located and when they move from location. Because if you map coverage of the network and the base station that received you, the gateway that received you moved, that coverage you map doesn't, it's not true anymore. So we need to hide that from the map. So this is I think, 20,000 gateways that have ever been seen on the Things Network. Anyway, getting back to my talk, I'm quickly going to tell you about what I'm doing in Southern Africa, and then some updates on the TTN Mapper project, and then hopefully there's time for some comments. So with the Peace Parks Foundation, we built this LoRa network in Zambia. The Peace Parks Foundation is a non-profit that has been started by Dutch and South African parties to improve the movement of wild animals. So normally what you'll do is you'll create these trans-frontier parks and you'll break down the border fences between countries so that these wild animals can move freely. The problem is you're using, so in these parks you actually have people living there and they are normally farmers like the farmers you see in this picture. Now these farmers, they want to farm, you have the wild animals come at night and they do wrong things on the farm. So we use IoT, different types of sensors, for example, weather sensors, weather stations, soil moisture probes, to monitor what is actually going on in this field. Maybe a good one will be the paint on some of their houses, and you can measure if animals come close by night. That's actually a good idea. Or passive infrared sensors. Yeah, so that's about what we're doing in Zambia for Peace Parks Foundation. But Peace Parks Foundation isn't the only one. If you Google a bit for IoT in Southern Africa, you get, for example, this Arable Labs. They're also building weather stations in the same location in Zambia. So there's actually a really good reason for using the Things Network and not a private network. So now, in this photo here, you'll see there's a cell phone mast up there of about 100 meters high. That's incredibly high. And the area is very flat. So what you see here, it's the Zambezi River's floodplain, really flat. So you'd assume if you put a gateway up that mast, you'll get an incredible range. So what we did is, that's difficult to put up there. But anyway, so what we did to start with, what you see here in this photo is a school in Zambia. So it's a really small building, but one of the few places that has electricity. So it's one of the few places we can actually install a LoRa gateway and power it. So behind the Wi-Fi grid you see there, up on that 6-meter mast, is a curling gateway. And yeah, we thought this is going to work. Compare the height of the gateway to the height of the tree. The gateway is sort of above the tree. But this is, on TTN Mapper, the coverage we actually measured for this gateway. And you'll see the furthest point, well, the most furthest point is about 2 kilometers, and there's a cluster at 1.4 kilometers, but actually we only have coverage in a 500-meter radius, which is really disappointing. So with a bit of social engineering, we got access to that big mast. But so anyway, this is a simulation of that same location, 6 meters above ground. It looks like we should get in 10 kilometers, but clearly, because of the trees, we only get 500 meters. So getting back to that 100-meter high mast, we got location for the gateway on that. We installed it at 20 meters above ground. So 20 meters, not at the top, only 20 meters high, because we also need to run Ethernet up to power it. There's a SIM card in the curling gateway, a global roaming SIM card. And this is actually a mobile phone mast. So we assume GSM from this mast should work. In theory, yes, it should, but in actual fact, the gateway didn't connect that well to the cell phone mast, to this mast, because we sat below the antennas. And those antennas are really directional. Interesting thing is, this gateway, because it's so high, and the Zambezi River you see here at the bottom, that's the border with Namibia. Our gateway connected to a Namibian network in the end. And our global roaming SIM card didn't have provisioning for Namibia, which meant we paid really a lot per megabyte. So that's one problem, one thing to keep in mind. Anyway, on this map, you see we got about 8 kilometers of range after we installed the gateway at 20 meters height. On the right here, that's one of the farms we actually need the coverage at. So this was not good enough for us. So we got approval to increase the height of the gateway. So we moved it to 40 meters high, or 45 meters high. And you can clearly see the coverage actually improved. So anyway, just to sum up our challenges. So we were not able to get the signal of LoRa through the trees in Zambia. Because here in Europe, if you see a tree, normally you have a row, and you have a row of trees, and behind the trees you have an open field again. Here in Zambia, if you have trees, it's a big, thick forest. So your signal doesn't go through the trees because you have more trees behind it. The GSM network in Zambia was unreliable, but it's also because we were below the antennas, and the radiation pattern of the antennas didn't allow us to connect directly. So we connected across the border to Namibia. That's really expensive. So global roaming SIM cards are really useful, but it can be very expensive. And one of the limiting factors, of course, is you can't install gateways everywhere. You need electricity, and you need a backhaul connection. We are lucky, though, because the mast we installed the gateway on is not the only one. We have about 4 more of these masts in the vicinity. So in theory, we can cover the entire area with LoRa. So now you see again the children, they were like really intrigued by this box. They are flashing lights on this and a toggle switch, big antenna. They started calling this the detonator. And at work, we still call this the detonator. So this specific box is actually an open source hardware design of me and Kulain. If you're interested in building one of your own to map coverage for the Things network or whatever network you're using, the design is on GitHub. Please feel free to use it, build it, contribute if you want. That brings me to part number 2, updates on TTN Mapper from the past year. After last year's conference, I was nominated for Shuttleworth funding for TTN Mapper. The funding went through. It's a flash grant, so it's not a lot of money, but it's enough to get me here today. So thanks to the Shuttleworth Foundation, I'm here today. And thanks to them, TTN Mapper is hosted for the past year by funding from them. One of the things that I had to do is to open source the entire system. So the entire TTN Mapper is open sourced on GitHub at the URL you see there. And currently, we're busy rewriting the backend and the front end, and everything will be open sourced on that repository. Since last year's conference, last year my talk was about processing 3 million data points, visualizing 3 million data points. I'm happy to announce this year we're on 30 million data points. It was not easy. Getting the system to run for another year was a few nightmares. Even the past week, I had 2 days that I thought the system is going to crash now. Because we're rewriting version 2, all my effort is going into version 2 and not maintaining the current one. So things like this growth is a bit hampering the development of version 2. I also, in the past year, had to rewrite the Android app. So this is a screenshot from the new Android app you use to map coverage. So maybe just to update, a quick explanation. The boxes I have here, they're GPS trackers. So the GPS tracker sends its own location, and the gateway measures the signal strength. If you have a device that doesn't have a GPS in it, you can still send a packet to the network and use the Android app to receive the packet from the network. The Android phone or the iPhone's GPS are used to get your location, and with the signal strength from the network, it's sent to TTN Mapper to draw the maps, which I'll show you some examples of now. So the reason for this rewrite was Android 8 and 8.1 was released, and they were really strict about background connections. The previous version of the app used an MQTT connection to the Things network to receive packets, and the way we handled it was not correct according to Google, so we had to rewrite the app to get everything the architecture correctly according to what they want. This app is also open source, so as you can see here, it doesn't look that nice yet. It's fully functional, but the user interface is not great. So if you are an Android developer and you would like to contribute to the project, please feel free. The code is on GitHub. Another thing that happened the past year is an official integration on the Things network. So if you log into the console and you go to integrations, you'll see TTN Mapper there. You just enable the integration, and assuming you have a GPS tracker, sending its own location to the network, you can specify a payload decoder. As long as the payload decoder gives out your data, latitude, longitude, altitude, you can enable this integration and your data will appear on TTN Mapper, which makes it much easier to do than in the past. And I think this is one of the main reasons why we went from 3 million to 30 million. So I was talking about, we're busy with a rewrite. So what you see here are some screenshots from our planned version 2 web interface. You will be able to log in to the website and see your own device and your application's data, which means you can also delete your own applications. That's very important for privacy, and that's something we can do at the moment, but with a bit of effort, you have to email me to delete data. So with a new version, you can log in yourself, delete data. If you mapped around your house and you don't really want your house to appear on the map, you just delete the data. The backend is still a mess. The new rewrite is written in Golang to follow the same example as the Things network. We run it in Docker containers. We're using RabbitMQ, message queues in between. At the moment, we're still planning to use MariaDB for the database, but I'm considering a few others. So if you have any recommendations what one can use for mapping data, maybe post to GIS, please come and talk to me. And static files like map tiles and coverage layers that we want to serve out via CDN to speed up the website. This is what the website currently looks like. This is Cape Town you see in front of you. Because we mapped so much, you actually can't see a lot. It's just a lot of radials over each other. If you look at only one gateway, however, this forms a really nice picture. So you can see this specific gateway has a range of 50 kilometers to the west and about 60 kilometers to the northwest. I'll come back to this gateway because this gateway is actually quite famous. This is what our heat maps look like, which we draw from the mapping data. This is the same picture I showed you last year. We'll still have the same maps on our version 2 system. And this is our alpha shapes, which I also explained in my talk last year. We'll still use the alpha shapes as well. But because we're rewriting, we can also add some features. So what you see here is a map of where the colors don't specify the signal strength, but the number of gateways that received you. So in this case, blue is 1 gateway received packets in that square. Green is 2 gateways, orange 3, and red is 4 gateways or more. The reason why this is important is if you want to use Colos or other triangulation service, you need 3 or more gateways. So those services will only work if you're in a red square on this map. Who played Age of Empires when they were younger? Yay. So you must remember the fog of war of Age of Empires. I always loved to explore the whole map so that I can see everything. So that gave me an idea. Let's implement the same feature for TTN Mapper as well. So what you see here is fog of war. So let's discover the entire world for the Things network. You can clearly see the Things network is being used the most in Europe. I have to add, this isn't all the mapping data. There's only a subset we use to test the new backend. But clearly the most data in Europe because we have the most users there. So let's just zoom in on the Netherlands. So when you zoom in, you see the highways are the ones that are mapped first, and cities, especially the city up in the middle. That is Apeldoorn, Amersfoort. It's the Meijers project with their weather stations. They also deliver data to me, and that's why Amersfoort, not Apeldoorn. It's confusing why that is mapped so well. So before I take questions, this is a screenshot from Doctor Who. Last year there was a new Doctor Who season. And I think in the second episode, this scene, this guy's standing on a beach, you have the sea there, and you have some mountains on this side, and the mountain peak here, that mountain peak, we have 2 TTN gateways on that mountain peak. So we can officially say the Things Network was on TV in Doctor Who. So I think there's some time for questions, I hope so.
Sure, we've got time for questions, and I hope there are questions, because this is awesome stuff. Good. I'll hold this for you. Do we have questions for JP?
Please, any recommendations for the back end or front end?
Yeah, Android programmers, we've got somebody over there. Not that you're an Android programmer, but you have a question or a remark. And I'm doing it from here. Thanks.
Hi, JP. You probably already know what I'm going to ask, but will you be able to make it a little bit easier for us gateway owners who sometimes have to rename our gateways but want to keep the same data?
Yes, that is a problem. I know you emailed me a lot about it. At the moment, with the current backend, it's difficult because because the gateway has a new name, the data is associated with the old gateway. I can move the data across easily, but because the gateway has been seen to come online at a certain date, and the data has come before that, I need to then move that date when the gateway was first seen back as well. So it's a lot of things to do, and I need to keep in mind to move everything before it works. But yes, with the version 2, when you can log in theory, you should be able to rename your data, say when your gateway was actually seen at the location. So we are planning to add a feature to make it easier, yes.
On to the next question. I've seen you. You're first.
Hi. So I saw your presentation when you show about on the gateways in Namibia.
Yes.
Do you think there's quite a lot of potential for deploying LoRaWAN in Africa as a whole, especially the fact that we've seen a lot of tech coming in Kenya, Nigeria, and maybe Namibia?
Yeah, I think Kenya and Nigeria specifically, they're really developed countries what mobile communication is concerned. But countries like Namibia, Botswana, Zambia, it's really sparsely populated. So the mobile providers, they don't have so many towers. So your mobile phone coverage is really bad. And they don't have incentive to expand the network. So what we want to do on farms, we're really far from the village. The village has mobile phone communication, but on the farms not. So using LoRa, we can extend the range of your cell phone network. So I think there's a lot of things to measure. So there's a lot of potential, but we need the connectivity. So I definitely think there's a reason to build a LoRa network, and I personally think it should be connected to the Things network. I hope I answered your question.
We have another one here.
Hi. I was just wondering if you could talk a little bit more about the social engineering that you described necessary to get that gateway on a cell tower, and
yeah, you see that.
and the actual process, physical process of getting.
Okay, so this I told you it's a project I did with the Peace Parks Foundation. Because it's a non-profit, they have really good ties with other non-profits. So specifically, we got access to this mast via another non-profit that actually provides Wi-Fi connectivity to schools. And that's specifically why we had access to the school at the beginning. So what they'll do is on the cell phone mast, so this non-profit that provides Wi-Fi, they had sponsorship from MTN that owns the mast. And MTN said, yes, you can use our mobile phone network as backhaul, and then you can use Wi-Fi from our mast to the schools to provide Wi-Fi for the schools. And then, of course, the NGOs help each other. So that's what I actually meant with social engineering. There are a lot of other social engineering stuff you also need to do when you run a network like in Cape Town. Access to a mountain like that, it's really difficult. but it's again like some people already have access and they say, yes, it's fine, we'll host the gateway for you. So this owner of the site, they know about it, but they don't really care because they're renting space out, and there's people that have the space, that are paying for the space, they really want to support the Things network.
Haven't seen any more questions so far, so let me ask you the last one. What are you here presenting next year?
Yeah, that's a good question, because last year was TTN Mapper, this year was African TTN Mapper.
Yeah, so what's this year?
Space and TTN Mapper, I hope, with
We'll talk with
Lacuna.
Elon Musk.
Yeah, with Lacuna Space and Thomas Telkamp out there with the satellite hanging in the roof. Maybe, why can't we map
would be
space as
awesome.
well?
I
Yes.
hope you're back next year. With
And then
space
Africa will be covered with TTN as well.
Exactly. Ladies and gentlemen, JP Meijers.
Thank you.
Nice. You got the stuff? Yeah.